So how do we select the root bridge? So as I mentioned, this may be A, this may be B, and this may be C. It doesn't really matter. Now, assuming this A, which is this switch, has a MAC address of AAA, and this device has a MAC address of BBB, and this device has a MAC address of CCC, the switches, these are their MAC addresses. Now, in order for us to decide who our root bridge is, between the three devices, they'll ask themselves questions. Hey, they'll send what we call a BPDU. BPDU. It's called a bridging protocol data unit. We'll look at that later, but basically it's just going to send a message from these ports to say, hello, I am, so this guy will send it, this guy will also send it. So this guy will be sending and say, hey, I am BBB. This guy will send it, hey, I'm BBB. This guy will say, hey, I'm AAA. And this guy will say, hey, I am, maybe this guy will also say, I'm CCC, CCC. This guy will say AAA. And also from the perspective of all the devices, they will get to know that, okay, this guy, switch A will know that, okay, there's a guy called BBB. There's another guy called CCC. Switch B also know that there's a guy called AAA and there's a guy called CCC. Switch C also know that there's a guy called AAA and there's a guy called BBB. They need to decide who will become their leader. In order for them to decide, they use what we call, they do the election process. The election process is saying that we need somebody who has the lowest bridge ID. And when we say bridge ID is a combination of what we call priority number plus technically your MAC address. I don't want to go into the detail, but let's say your MAC address. So the priority number plus MAC address will give you your bridge ID. And so from the perspective of this device, the bridge ID for this device, so as I said, it's going to send A, it's not really true. It's going to be sending, by default, the priority number is 32, what's the number? So it's 36, no, 63 something. I'll get back to you on the number on top of my head. It's too much information, but I think it's 32 something or 36 something. Now that number, let's assume it's 3, let me see. By default, it is 3 something. We'll see that when I check the switches. But normally, assuming it is, let's say 3, maybe 36503 or something, or 53, 3653. Let's assume it's 3653. So it means that the bridge ID of this device will be 3653:AAA. This is the bridge ID. This is what it actually sends to this device. This device will also send 3653 as the bridge ID for this device. This will send 3653:. And so from the perspective of the three devices, even though it's sending all this, what they care about is the MAC address, because if you look at it from the beginning, all of them have the same priority number. And so it boils down to the MAC address. So we'll be looking at the one with the lowest MAC address by default, because by default, Cisco devices will all have the same priority numbers. So we'll be looking at the MAC address. Between the three switches, the one with the lowest MAC address, which is this guy, switch A, it has a MAC address of AAA, is the lowest. BBB, so basically in hexadecimal, base 12, when we see A, it means 10. When we see B, it means 11. When you see C, it means 12. So between 10, 11, and 12, 10, which is A, is the smallest. And so we'll choose this device as our root bridge. And that's how we get to define who our root bridges. And also means that the other devices will become non-root bridges. It means that what it means is that we're not going to be using that as our main point. If you want to talk to this guy, we cannot go directly. Non-root bridges will not communicate directly. They will have to go to the root bridge. It means that this guy will be going through this and this guy will be going through this. And this is how spanning tree detects who our root bridge will be.